10 years before the world started treating AI like a destiny, there was a man who kept repeating a sentence that sounded almost boring if you did not understand what it meant. The future of intelligence, he said in different ways, will not be built by writing more rules. It will be built by building machines that learn. That man was Geoffrey Hinton. And if you only remember him as a famous professor or as a pioneer of neural networks, you are missing the thing that made him dangerous in the best possible way. He did not just have ideas, he had patience for being early. He had the stomach to be laughed at, ignored, underfunded, and still keep walking in the same direction because he believed the underlying mechanism was correct. To understand what it means to see AI coming 10 years before everyone else, you need to understand the atmosphere of that time. There were years when the very phrase neural network felt like a career risk, not because the math was nonsense, but because the world had tried versions of it, failed, and moved on. People wanted systems they could control and explain. They wanted logic, explicit rules, clean pipelines. They wanted an engineer's confidence. Neural networks, by contrast, felt like you were growing a machine instead of building one. It learned internal patterns you could not fully narrate. It was statistical. It was messy. And if it failed in ways that made skeptics feel smart. Hinton kept returning to a deeper intuition. The brain does not run on handwritten instructions. The brain is a learning device. It shapes itself through experience. It compresses reality into representations that become useful. If biological intelligence emerges from learning, then machine intelligence should emerge from learning too, provided you have enough data, enough compute, and an architecture that can actually absorb the information. That belief sounds obvious now because you live in a world where your phone recognizes your face, your headphones understand your voice, and a model can write a decent paragraph in a second. But back then, the belief was a bet against the dominant culture. And it was not a vague bet, it was a precise claim about scalability. Hinton believed that the right systems would improve predictably as you increase three things: the amount of data, the amount of computation, and the capacity of the model. He was not promising magic, he was promising an industrial curve. That is the key difference between people who are early and people who are lucky. Lucky people get one win. Early people understand a mechanism that keeps winning as you scale it. But why did it take so long for everyone else to see it? Because the field had scars. AI had gone through winters, periods when funding dried up, and confidence collapsed. Promises were made too loudly, too early, and when hardware could not deliver, people became cynical. In that environment, the safe career move was to work on systems that already looked respectable, systems that could ship value now. Hinton did the opposite. He stayed close to the idea that looked immature but fundamental, the idea that once the ecosystem caught up, it would dominate. Here is what the public often misses. The ecosystem is not a footnote. The ecosystem is the difference between a theory and a revolution. Neural networks can be described with simple equations, but training them at meaningful depth requires enormous matrix operations, done repeatedly over huge data sets. That is not an intellectual barrier, it is a physical barrier. It is electricity, silicone, memory bandwidth, and the cost of moving numbers through a machine. For years, compute was the bottleneck, data was the bottleneck, training stability was the bottleneck. The world looked at neural networks and said they are flaky. Hinton looked at the same thing and said they are underfed. Then the world quietly acquired the missing pieces. Digital life produced oceans of data, cameras, phones, microphones, the internet, every click an image and caption. Meanwhile, GPUs, originally designed to accelerate graphics, turned out to be perfect for the parallel math that neural networks crave. And researchers learned practical tricks that made deep networks train reliably, layer by layer, without collapsing into uselessness. This is what a real revolution looks like. Not a single lightning bolt, a slow stacking of infrastructure until the moment the stack becomes tall enough to change everything. In that context, one event became the public signal flare. A deep convolutional network won the ImageNet competition by a shocking margin. The names on that work mattered, and Hinton's name was one of them. But what mattered more than the trophy was the meaning. It said the curve is real. It said scale works. It said learned representations are not just elegant, they are powerful. After that moment, deep learning was no longer an opinion. It was a competitive advantage. And when something becomes a competitive advantage, corporations, governments, and entire economies start reorganizing around it. This is where the story becomes personal for you, because the same pattern that played out inside research labs is now playing out in every profession. For years, AI looked like a novelty. Some tools, some demos, some hype. Then suddenly it became undeniable. And that suddenness is not because AI was born overnight. It is because the ecosystem crossed a threshold. Most people do not notice a threshold until they are already on the other side of it. Hinton did. He understood that Once a system learns representations, you can reuse those representations. That is the secret sauce behind why deep learning spreads so fast. A model trained to detect edges and shapes becomes useful for identifying objects. A model trained to map sounds to words becomes useful for translation. A model trained to predict the next token in language becomes useful for writing, summarizing, coding, tutoring, planning. The representations are general. And general representations are like infrastructure. They can be applied again and again. So when you ask, who saw AI coming early? Do not reduce it to a single prediction like, in 10 years there will be chatbots. That is not what he saw. He saw a manufacturing method for capability. He saw that intelligence could be produced through scale. And once you understand that, you stop thinking about AI as a tool. You start thinking about AI as a factory. That is the frame you need if you want to understand what is happening right now. Because the world is not being disrupted by a clever app. The world is being disrupted by the ability to manufacture cognitive output at near zero marginal cost. Writing, summarizing, drafting, translating, brainstorming, coding assistance, all of it starts to behave like electricity. It becomes abundant, it becomes cheap, it spreads everywhere. And when something becomes abundant, the value shifts away from the thing itself and toward the ability to direct it. Taste becomes valuable, problem selection becomes valuable, integration becomes valuable, distribution becomes valuable. The person who can aim the factory becomes more important than the person who can produce one unit by hand. This is why you feel a strange tension in the air. Because a lot of people are still using AI like a toy, like a novelty, like a curiosity. Meanwhile, a smaller group is using it like a production line. The gap between those two groups will not be small. It will be massive. And it will show up as speed, output, experimentation, learning rate. The ones who treat AI like a factory will run 10 iterations while others run 1. They will test ideas faster, they will launch faster, they will adapt faster. And the reason you need to hear this now is because the phase change is not done. The first phase that captured the public was language and content. The next phase is action. Models that not only generate text, but operate workflows. Models that use tools, call APIs, search data, write code, run tests, interpret results, revise plans. That is the direction. That is where the curve is pointing. The same way image recognition moved from research to infrastructure, tool using intelligence will move from demo to default. So when you think about Hinton seeing it early, understand what that means for you. It means you cannot judge the future by the current roughness of the tools. Early tools always look clumsy. Early airplanes looked unsafe. Early computers looked useless. Early internet looked like a toy. The question is never, is it perfect today? The question is, does it scale? And the deeper question is, do you have a strategy that benefits from scaling? Because here is the mistake people make when they are watching a curve like this. They assume progress is a straight line. They assume next year will feel like this year, just a little better. But scalable systems do not improve like that. They improve slowly at first, then rapidly, then the entire environment changes so much that it feels like reality itself got patched overnight. That is what you are living through. And the man who saw it early was simply refusing to ignore the math of scale. Now let us zoom in on the decade where the prediction moved from whisper to earthquake. Because this is the decade that taught the world a brutal lesson about how fast capability can compound once you remove the bottlenecks. After ImageNet, deep learning did not just win one benchmark and stop, it marched into everything that could be represented as data. Speech recognition improved. Machine translation improved. Recommendation systems became more predictive. Computer vision went from detecting objects to understanding scenes. And each success had the same underlying signature. More data, more compute, better architectures, better training methods. Then the transformer arrived. And it changed the game again, not because it made models slightly better, but because it made scaling much easier. The transformer architecture allowed training to be more parallel, more stable, more efficient at large sizes. And when scaling becomes easier, the pace of progress accelerates, because fewer things break when you make the model bigger. That matters more than most people realize. The world loves to talk about intelligence like it is a mysterious spark, but in practice, modern AI progress often looks like engineering discipline plus scale. This is why people describe recent years as an explosion. It was not one leap, it was a chain reaction. Once you could build bigger models effectively, and once you had the compute, and once you had the data, you started seeing a consistent pattern. Larger models trained on more data tend to learn more general capabilities. Researchers started formalizing this with scaling laws. The idea is simple but terrifying. If performance improves predictably with scale, then capability is not just a research novelty. It is an investment plan. It becomes something you can forecast, finance, and industrialize. At this point, the AI story stops being mainly about academics and becomes about infrastructure. Whoever controls the most compute, the best chips, the best data pipelines, the best talent, and the best deployment channels gains an advantage. And this is where the world begins to look different, because now AI is not just a feature inside software. AI becomes the engine that makes software. It becomes the engine that improves itself through iteration. It becomes the engine that compresses labor and cognitive tasks. You should feel the implications. When a tool compresses labor, it changes what skills are rewarded. It changes what jobs look like. It changes what businesses look like. It changes what education looks like. It changes who has leverage. And leverage is the hidden currency of the modern world. Leverage is what lets one person do the work of many. AI is leverage, not in a motivational poster sense, but in a very literal economic sense. So the question becomes, how do you, as a person, ride this wave instead of being dragged by it? The answer is not to panic. The answer is to adopt the correct mental model. Remember what we said earlier. The world is splitting into people who use AI like a search engine and people who use it like a production line. The production line mindset is about building repeatable workflows where AI is one component in a chain. Here is an example you can understand without being technical. Imagine two people trying to create a YouTube channel, a business, a portfolio, a newsletter, anything that requires consistent output. Person one uses AI occasionally to get ideas or to fix grammar. Person two builds a pipeline. The pipeline starts with research prompts that generate multiple angles. Then it runs through a fact-checking phase. Then it runs through a drafting phase. Then a critique phase where the AI is instructed to attack the draft and find weak points. Then a rewrite phase. Then a hook optimization phase. Then a title and thumbnail testing phase. Then a distribution strategy phase. Person two does not just get a slightly better draft. Person two gets a machine that produces improved drafts repeatedly. That is the difference. One person got a tool, the other person built a factory. Now, take that mindset and apply it to any domain: student, entrepreneur, designer, analyst, marketer, manager, researcher. The domain is not the point. The point is building loops. The winners in AI are not people who ask better questions once. They are people who build better systems that ask, test, refine, and deploy questions continuously. This is precisely why Hinton matters. He did not win because he had one clever idea. He won because he believed in a mechanism that could be improved systematically. He believed in learning at scale, and that belief is exactly what you need right now. Because the next phase of AI is not about generating text. It is about agents in action, about systems that can run tasks across tools, about models that can perceive, plan, and execute. But let me make this more concrete, because otherwise it sounds like abstract futurism. The next shift is already visible in the way AI is being integrated into work. AI assistants that can write code are not just code generators. They become collaborators that reduce the friction of building products. AI that can search internal documents becomes a memory layer for organizations. AI that can operate spreadsheets, generate reports, and interpret dashboards becomes a compression tool for analytics. AI that can draft emails, proposals, and presentations becomes a compression tool for communication. Each of these compressions changes the value of the human role. Humans move upward into direction, decision-making, taste, and accountability. And here is the psychological trap. Many people will look at that and feel threatened because they are identifying with the labor that is being compressed. But the correct move is to identify with the outcomes, not the method. If the outcome is communication, then you can still own communication while AI drafts faster. If the outcome is analysis, you can still own analysis while AI produces summaries. If the outcome is education, you can still own learning while AI tutors you. But only if you shift your identity from doing the work manually to directing the work intelligently. This is why the people who are most vulnerable are not the least skilled, but the most rigid. People who refuse to change their workflow. People who treat their current process as sacred. People who think dignity is tied to doing everything by hand. That mindset will get punished. Not by evil, but by economics. In a world where capability can be manufactured cheaply, the market rewards those who can direct capability toward valuable outcomes. And this leads to another uncomfortable truth. AI will not eliminate all jobs. It will eliminate certain tasks. It will also create new tasks, but the transition will not be evenly distributed. The disruption will hit wherever there is repetitive cognitive labor that can be learned from examples. That is what representation learning enables. If there are enough examples of a task, a system can learn the patterns. If it can learn the patterns, it can perform the task. If it can perform the task cheaply, the labor market shifts. So what do you do with that? You build a strategy that makes you harder to replace, not by being more human in a poetic sense, but by positioning yourself where AI needs you, where accountability exists, where decisions involve context, where taste matters, where relationships matter, where goals are ambiguous, where the work is not just producing tokens, but defining what should be produced and why. And here's the moment where many people misunderstand. They think the safe move is to learn the most technical skill possible, like coding, because that feels like building a moat. But AI is already compressing coding, not eliminating it, compressing it. The safe move is not one skill. It is adaptability plus domain understanding plus the ability to build systems with AI. The new literacy is not writing code. The new literacy is specifying intent clearly, decomposing problems, validating results, and integrating outputs into reality. That is why Hinton's story matters as a template. He trusted the scalability of learning. You should trust the scalability of integration. The people who thrive will be the ones who integrate AI into their workflows faster and more intelligently than others, and who use that integration to produce results, not just content. Now notice what we have done. We started with one man who saw AI coming early, and we turned it into a question about you, because that is what matters. History is useful only when it gives you a weapon. The weapon here is a correct mental model, scalability, pipelines, leverage, and there is another layer coming, the layer that will make today's language boom look like the warm-up. It is the collision of AI with the physical world. Robotics, autonomous systems, manufacturing, logistics, healthcare devices, simulation-trained policies. When the representation learning mindset moves from pixels and tokens into motion and force, the world changes again. And the same people who were late to language models will be late again, because they will judge robotics by what it cannot do today, instead of what the scaling curve implies. The reason I am emphasizing the physical world is not to scare you. It is to make you see the repeating pattern. The pattern is always the same. First, a concept exists in research. Then it looks brittle and unimpressive. Then the ecosystem builds around it. Then it crosses a threshold and becomes inevitable. That is the arc Hinton understood. It is the arc you must anticipate in the next phase. Think about what the internet did. At first it connected a few machines. Then it became communication infrastructure. Then it became commerce infrastructure. Then it became culture infrastructure. AI is on the same path. At first it was classification, then it was perception, then it was language, now it becomes action, and after action it becomes coordination. Systems coordinating other systems. Organizations where a small number of humans direct fleets of automated processes. This is the point where you need to ask yourself a very direct question. In a world where intelligence can be manufactured, what will you manufacture? Because if you do not choose, you will drift into being a consumer of manufactured intelligence. And consumers do not control the future. Producers do. So let me give you a vision you can actually use. You do not need to become a research scientist. You need to become a builder of loops, a builder of systems, a builder of repeatable processes where AI multiplies your output. And you need to anchor those loops to a domain that has real demand. Start with something simple and brutally practical. Pick one recurring task in your life or work that currently takes you hours. Researching, planning, drafting, studying, organizing, writing, editing, summarizing. Then design a workflow where AI does the first pass. Then you do the decision pass. Then AI does the refinement pass. Then you do the final accountability pass. That alone can cut the time in half. But do not stop there. Add checkpoints that force quality. Add an adversarial step where the AI tries to find weaknesses. Add a verification step where it identifies what it does not know. Add a step where it proposes alternative strategies. Now, you are not just using AI, you are running a process. This matters because the future belongs to people who can run processes faster. Speed is not just productivity. Speed is learning. If you can iterate faster, you can test more ideas, get more feedback, refine more quickly, and find what works before others even start. This is the hidden advantage of AI. It collapses iteration time. That is exactly what happened in deep learning research. Faster compute meant faster experiments. Faster experiments meant faster learning. Faster learning meant more breakthroughs. The same logic now applies to individuals. Now, let us talk about the emotional side, because that is where most people get stuck. People want certainty. They want to know which job is safe, which skill is safe, which path is safe. But the entire point of a phase change is that the old certainty breaks. The new certainty is adaptability. The new certainty is being close to the tools and close to the demand. That is why the people who win in tech shifts are often not the ones with the highest raw IQ, but the ones who are willing to rebuild their workflow without ego. Hinton's career is a lesson in ego control. Imagine being told repeatedly that your approach is obsolete. Imagine being in an environment where funding follows trends, and trends follow fashion. Imagine watching the world celebrate other methods while you keep working on the one that people mock. The reason he could do that is because he had internal conviction in the mechanism. He was not chasing applause, he was chasing the curve. You need a version of that conviction now. Not conviction in one tool, because tools change fast. Conviction in the principle. The principle is that AI will keep getting more capable as ecosystems scale around it. Models will get more multimodal. They will get better memory. They will get better tool use. They will get better reliability. They will integrate into operating systems, business software, and devices. The question is not whether, the question is where you will be standing when that happens. If you stand outside it, you will experience it as replacement pressure. If you stand inside it, you will experience it as amplification. That is the fork. And the fork is not philosophical. It is tactical. It is about whether you build with it. Now, I want you to think about the next 10 years the way Hinton thought about the previous 10. He did not predict the exact products. He predicted that representation learning would dominate because it scaled. You do not need to predict the exact winners either. You need to predict the shape of the shift. The shape is integration and action. AI moving from producing content to producing outcomes. That means your edge will come from understanding a system end to end. Not just generating pieces, but owning a pipeline from intention to result. If you are a student, that means learning to use AI to generate explanations, quizzes, study plans, and practice problems, then validating understanding through recall and application. If you are a creator, it means building a content pipeline that produces consistent output with research, drafting, critique, and revision loops. If you are a business builder, it means integrating AI into customer support, marketing, analysis, and product development to move faster than competitors. If you are in a traditional job, it means becoming the person who can redesign workflows with AI and make the team more efficient. The person who becomes the translator between human goals and machine capability. And there is one more layer you should not ignore. Trust. In a world where content becomes abundant, trust becomes scarce. Anyone can generate text. Anyone can generate images. Anyone can generate a proposal. But not everyone can be trusted. Not everyone can be That is where humans remain central. The people who will be most valuable are those who can combine AI speed with human responsibility. They will verify, they will cite, they will test, they will correct, they will own the outcome. This is why simply using AI is not enough. You must become the person who can turn AI outputs into reliable results. That is a skill. That is craft. That is where careers will be built. Now look back at the title in your mind, The Man Who Saw AI Coming 10 Years Before Everyone Else. The reason that title works is because it feels like a warning and a promise at the same time. A warning that the world changes faster than comfort allows. A promise that those who can see early can position early. You do not need to be 10 years early. You just need to not be 10 years late. And if you want to know whether you are late or early, here is a simple test. Are you building workflows that depend on AI? Or are you occasionally playing with AI? Playing is fine, but playing does not compound. Workflows compound. Pipelines compound. Systems compound. The people who will look back and say, I saw it coming, will not be the ones who watched videos about AI. They will be the ones who built something with it while everyone else was debating it. So do not make this abstract. Choose one pipeline this week. 1. Build it, run it, improve it, then build the next. And as you do that, you will feel something shift inside you. The fear will shrink. Not because the world became safer, but because you became more capable within it. Because that is the final lesson of the man who saw it early. The future does not belong to the people who predict it. It belongs to the people who adapt to it faster than the average person is willing to.